Hi, everyone. Welcome to this introduction to large language models. If you've ever wondered what's happening when you type into systems like ChatGPT, Claude, Grok, all these different LLMs out there, or large language models, or any AI assistant, I want to kind of just break it down what's going on behind the scenes, looking a little bit under the hood and understanding a little bit of the technology and how it works is actually really vital to using the technology correctly. As with the rest of CrossGen AI, I do promise to try to keep it to a technologist level. But I do encourage people to kind of go down the rabbit hole just a little bit. By the end of this video, I hope you understand a little bit how the LLMs work, specifically the idea of next word prediction, what tokens are, and why it really matters. So you stay away from this concept called hallucinations, or when AI makes things up with authority. So let's dive in. As always, we have our disclaimer. CrossGen AI is a community-driven learning platform that bridges the gap between tech and non-tech, between business and engineering, and across generations to help professionals actually use AI, not just read about it. AI is fast-moving. Course materials may become outdated. Always check for the latest before fully relying on community advice. The examples and explanations I use are designed to make AI concepts practical and approachable, even if they sometimes are simplified and not technically airtight. The goal here isn't about being a walking AI textbook. It's to help people think about AI in a way that's useful in real world use cases and workflows. If you're using AI for business purposes, it's crucial to understand your security requirements for your organization. But it's also important to be mindful of AI usage in your personal life. Never put passwords and highly sensitive personal data into AI tools. We strongly recommend using paid tools from reputable companies and ensuring your data settings are aligned with your security needs, especially when dealing with sensitive or proprietary information. While feedback is always welcome, please understand this is about practical education to get to real world use cases. Okay, so let's just start with a simple explanation that this concept of large language models, or LLMs, is really just next word prediction, or what people will call autocomplete on steroids. And so I'm just sharing my Gmail here. I think people have seen this with new apps in their lives in the past, I don't know, few years or so, where suggestions start to come up for the next word, right? So I'm gonna use this practical example a lot. Once upon, right? Autocomplete filling out there, right? If I push tab, it figures out once upon, right? It also likes the idea of, once again, but it's trying to predict what is the next word. And that is all it's doing. And so the idea is, what if I did this once upon a time and I user type once, and now I'm doing upon a time? Well, I predicted that. So shouldn't I be able to predict the next word after a time if I feedback the whole part of once upon a time? Should be able to predict the next word. And if I predict the next word, can I just take that whole section I just said, once upon a time, ogre, all right? We're going down the fairy tale path here. Um, if you're able to do that, it's this idea that, whoa, we can just predict the next word to the next word to the next word. And so it was really just sort of this autocomplete on steroids kind of concept. Fundamentally, the algorithms, these systems generally use on people call neural networks and all these other kind of things. They've actually really been around for a very long time. It really came down to compute power. And it also came down to realizing that if you just put more data in, you actually get better answers, which is maybe counterintuitive. I don't know, but that's sort of what's really happened here. We have enough compute power, put in larger and larger data sets. It gets better and better. Now, these days, certainly there's argument about DeepSeek and things like that, that are out there if you pay attention to the AI news world, where, they're doing it for cheaper because maybe it turns out you don't need a lot more data, but fundamentally more data, better answers. So yeah, so it's next complete. All right. Okay. Now it's time to look a little bit under the hood here about how these things work, these large language models. I'm going to describe it again at a very practical level. I hope people can keep up with me. I do think it's important for you to learn, replay what I'm saying, do a little more research on your own. You need to learn this stuff about AI to this level to understand how to use it correctly, properly in the future. Okay. So follow my arrow here, or my cursor. I'll make a little hand here. Okay. So first, it's about the development of a large language model. And the model itself, we're actually talking about the base model right now, and I'll explain that in a little bit. So there's things scrapes the internet. An example of that is called Common Crawl. I actually went through this and go to the Common Crawl website and look, it's Common Crawl contained petabytes of data collected since 2008. You can choose the latest model. So last one was run the '08 model in 2005 here. And I actually clicked on that and it will tell you, believe it or not, that you can get all these things off of AWS. And this way it's compressed right now is something like 82 terabytes of information. That is just a lot of data. Comes 2.67 billion web pages. Okay. So this is an example of actually just literally scraping all the words of the internet and saving them. It contains everything. So personal identifier information out there. If you put, your home phone number on a website you made, like it's in there. Just so you understand these models, you really gotta be careful what you put out there because these things sort of just suck up all the information that's publicly available and post it. And anybody in the world can now use this stuff in order to create their own large language models and everything else. So something like Common Crawl does that. So it scrapes the internet, saves it. Okay. So it takes those words and then actually to remove duplication of words, meaning like, this article, literally somebody cut and paste something on the internet. So sense in duplicating those kind of things in order to shrink the data set down. It may add some metadata about the quality of where that information is coming from. So it gives more, respect to certain websites that are more reputable in its content. And it removes PII or personal identifier information in many models. But again, you can go back to the raw internet from that Common Crawl example. So be very careful just in your future dealings. And so it scrapes out all information and then it puts words into what's called tokenization or tokenizer. Okay. The tokens are really just chunking up words, letters. It's not one-to-one. And we're going to show you examples in a second here of what that means. And that's a big takeaway today. And then just sort of this vocabulary of tokens. So you're taking words, making them tokens. The number of tokens varied by different models. So GPT-4o, as example, has 200,019 tokens. So all of the words on the internet are broken up lightly. It's not one words again, I'll show you. Are broken up to the option of 1 to 200,019 different numbers. That's it. So the word "the" is a number in most cases. That's one of those numbers, THE. Also turns out that space, THE, is another number. Llama, as you can see, is 128,000 tokens, and DeepSeek. This is not context window tokens. These are literally the vocabulary of the tokens. All the words on the internet fit into this. Okay. So an example out of that is called FindWeb. It takes it from scraping the internet to tokenization. FindWeb uses two called embeddings, which is really the tokenization, taking those words, making them to the vocabulary size of GPT-2. You can go to this thing on the Hugging Face website, and it's, this cool FindWeb, decanting the finest text at scale. You can go there and you can download this model. It's not a model. You can download this information, these tokenized compression of the internet, all the words, with all the PII and whatnot removed in this case. And it comes out to 15 trillion tokens. Okay. That's not the vocabulary size. That's how many vocabulary words there are. It's 15 trillion of those numbers, which is a compression of the internet effectively. And that's 44 terabytes of space. As you can see, it actually is derived from Common Crawl snapshots. Okay. And then they applied the GPT-2 tokenizer to this. That's my understanding. Anyways, that's how you can get to a tokenized version of the internet, but it stops there. The FindWeb is not predicting the next word. It's a data set if you want to go and make your own large language model in order to predict the next word. Okay. So out of these tokenizers, again, I'll show in a second here, comes these numbers, which are really the tokens of the internet. And now you actually are going to try to predict the next token in a series of events, no different than the once upon a time example I just gave here. I made this green because there's some context I'm going to show you later on. The green is what we call this neural network, which is really just almost addition and multiplication math. It is mathy, at the high ends, as we try to make these things more sophisticated, it does become a little, deeper math. But at the end of the day, if you learned how to do a neural network, it's not crazy to do it in a basic sense. And so out of the neural network, once this neural network's defined and you've trained it, which we'll get into about the next word prediction, that's really the base model. The base model comes out of that. And a base model is example GPT-4o. So the GPT base model And I just want to kind of clarify that right here. GPT-4o base model is not fine-tuned. It literally just predicts the next word. Okay. You do not generally have access to this, especially with OpenAI, but you can get the base models of other systems like Llama and stuff like that because they're open source. GPT-4o, when you hit it with an API, meaning they're not using ChatGPT itself, you're using your own software systems to go ask, it is then a fine-tuned model, which actually knows how to answer questions and kind of go back and forth, this interactivity that you have with it. Base model itself is not interactivity. It is next word prediction. We then fine tune it to be able to answer questions. And then certainly the ChatGPT you have is fine tuned, and actually it's fine tuned again for chat itself, how to be more chatty. So when you hit it with an API, you kind of get different answers occasionally, and you have to optimize it a little bit more when you start to get more deep into it. And when you're not using ChatGPT and you're trying to do things for your company or yourself later on. Okay. So that's what this is. All right. So the neural network itself, this sort of green thing, when it's trying to figure out what math to do in the green bar here. Okay. So you have a sequence of tokens. Again, every word became a token, and I'm going to show you some more specifics on that in a second. So you say the word I, and then viewing. The viewing is a total one word, but in this case, view and ing got broken up to two tokens because they mentioned not one-to-one on words all the time. And even this fine little part right here, this little space, see it, space single? That matters. The space matters. And you put in this neural network, and then it says probability of the next word in a number, which is predicting the next number, which you can always get the word right back out of it. And in this case, the correct answer should be 3962, which is down here, post, or 4% probability of that next number. These are the other probabilities of the other numbers. And what you do is you say, well, this is the real number because you have this whole internet there. The next number is, we know what the next one is from the internet compression. And then you pretty much change all the numbers within this green thing, or the math that happens, which is, think of them as weights, something from 0 to 1. You multiply this probability by that, and it comes out with a probability statement. You don't need to overly understand the green box at all. Just know that it's sort of multiplication that happens in order to give you the probability of the next word. And then models themselves pick what they should say. It is not always the next word, the highest probability word. There is tweaking that all the models do because you want some variation to it. You just want it to regurgitate the internet. You want some thought. You want to not just, start like a Wikipedia article, and you don't want it to complete that Wikipedia, or you want it to kind of use information from other places. And that's sort of why, especially when you're trying to interact with it and get it to do different, write an email for you or something, there's variability to it, right? It's not this hardened thing where, 5 years ago, that kind of interactions with the chatbots that still exist in many cases on websites. It's a very hardened, predictive thing. And this adds some human element to it, if you will, because there's this, not always the highest probability, but it's definitely in the higher probabilities. It's not picking like the 1% club in order to give you that answer. So that's how that works. Let's talk a little bit about this tokenization process. There is a link to this in the community. If you go to this tokenizer website, whenever you come in here, I'm going to have people X out this, what's called XML, right? These little kind of blocks. That's sort of what actually happens really behind the scenes. It's irrelevant for what we all need to learn. So we're going to use a tokenizer using the GPT-4o tokens. So these are the real tokens from the 200,019 tokens we talked about. And you're going to see what words go to what numbers. So we're going to do our once, upon, a, on. And on the blue, you match it here, right? So once is the number 18,049. And then upon, a, look, if you notice this is a space. So 7757 includes the space of upon. A, the letter A, with a space is 261, and then 1058 for a time. Okay. Now let's show you how, I'll say fickle, but really how this really understands context around capitalization and punctuation, things like that. The tokenizer, if I take out, or if we put an extra space in here, the space itself, the single space went with time. You see this little dot kind of that's showing up here. And then the single space without the A went to 220. So you'll find that 220 is the common for just the space unto itself. But believe it or not, if I put double space, it's 256. So it's not 220 is 220. Another one, it counts for 271 as 3 spaces, right? And you can see it's not going in numerical order either. And I got a bunch of spaces at this point in time. Okay. Comma. Comma is always a low. A ogre. All right. Now, here's a great example. Ogre, not a common word. Maybe is because it actually chunked it up, right? Space OR, or the letter space or, right, is 503. In fact, if I put the word or again, space, hopefully it kind of comes with 503. Yeah, there it is, 503 again. Okay. The colors are just help you link the top to bottom here. It's not meant to say this one, same, even though they are 503 and 503. Okay. Now, let's go here and actually make it capital O. Capital O is a different or, right? So here's your 5031, and now your or is still chunked up into 2604. But the capitalization mattered. I didn't know if it would actually grab ogre, but yeah, so it broke it up that way. Okay, so the spaces matter, capitalization matters. We go with little o once different, right? We go with space, it's different. If we go with the space and a capital O, okay, it's all different. With period, okay, in this case, period, force the once capitalization onto its own number itself, which is different from the space one, okay? So it all matters. What I kind of think of this is because it's not just predicting, like it's not the tokenization not being one-to-one on words, and we're spacing and all those things kind of come into it. It's kind of helping it leapfrog into context of it. So there's context in the space, right? Having that space provides context. It's not like the end of the sentence. And so it kind of helps it loop from, word to word in this autocomplete idea. And so this is what happens behind the scenes. When you type in ChatGPT takes all these numbers. And again, any LLM takes these words and it makes them into numbers. And then it puts those numbers back and it does the next word prediction by taking those numbers and putting them through here in order to predict the next probable word. Here's an example of that. And it keeps building this, right? It's not just like it takes it doesn't just take, like, if the number is 91, the next one that the neural network's going to predict that it's 860. It then takes 91 and 860 and puts out 280. It doesn't just take 860 without the 91. That will be a different probability of what the next word is because it doesn't have the context of the 91. So it's important to keep that. Okay. The context window for ChatGPT 4.0 is, I think, is 120,000 tokens, which is about like a Harry Potter size book of context that it keeps feeding for the next word predictor. So the more you put in the same chat line, the better it gets. But it will eventually lose memory if you go beyond 128,000 in that same chat line. And we'll explain more about those sort of the memory between chats and things like that, specifically around ChatGPT. I do recommend that one for beginners. I think the interface is nice, but all these things are generally the same at the end of the day. Okay. So this is called interference, by the way, when it's actually predicting the next token. Okay. So that's it on the tokenization side. Okay. So the other thing to start to do is if you go to this thing called Hyperbolic, you do have to sign up. Even though you see dollars and cents here, it's actually free to do what I'm about to show you. If you click on models, we're going to click on a base model here. I want to show you the next word prediction ability. You will not have the GPT world in here because for the base models, because proprietary. Again, you have to go to open source models here. So DeepSeek's open source, Llama, which is Facebook's, and you see it going to the base model. Okay. So it's not the question answer. This is the base model that we just talked about. Non-fine tuned. All right. So this is just next word prediction from an actual model that's already gone through the neural network and everything. We're going to stick with our once upon a time. And I'm going to copy this because we're going to use it over and over again. Okay. Don't know what's going to tell you. This is live, raw information. When I click this, it's going to predict the next word. Once upon a time, 20 years ago, a young man named blah, 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 et cetera, et cetera. Stop. Okay. Next. Once upon a time. Again, it does not always use the highest probability of next word, especially with once upon a time. That branches out to so many different things on the internet that it's a very spread out probability of the next word. It's not like hardened into once upon a time, blah, right? That's a very open thing that's often used. Okay. So I would not expect to get the 20-year-old next again. Okay. There you go. Boom. 6th Street. Okay. Next, we're going to do it again. Okay. You can see this is the probability aspect of it, where it doesn't always, it is not. In fact, in this case, I would arguably say you will never get the same answer with once upon a time, but it is just predicting the next word. Okay. And all these are next word predictor, next word predicting, predict, 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 predict. Okay. All right. So an important aspect here, and I never really pay attention to this, especially as you use these things for business. Okay. It's just the next word predictor, and it matters when you finished making your model. Okay. So you scrape the internet. Well, that's a moment in time that you scrape the internet. You do all this processing, things like that. This is not happening in real time. Once the base model is set, the base model is set. It is only the compression algorithm of the internet at that date and time in which the base model is finished. Okay. Nowadays you're seeing a little bit more stuff where it will search on the web to try to fill in the gap between, say, if it finished in November of last year is the model. It'll these things kind of know now. If you're not confident on it, especially something if you're asking about now, the probabilities of what's next are very low because it's not reinforced from the internet. If we're going to ask about the Super Bowl, for instance, who won the Super Bowl in 2025. So it's not actually in the model. So you're really going to almost get kind of predictions of what maybe like what Vegas is talking about. You were getting in November, you were getting, predictions of what maybe ESPN commentators are talking about, that kind of stuff. So it's not hardened probability at the time, especially if you're going to ask now. Now, again, the ChatGPTs of the world kind of go off and kind of fill it in with the internet. But be very, very careful because hallucinations still happen. And that's when it makes up the information, or we believe it's made up. It's really just not, it's just saying the next probability is this. Okay. All right. So go back to here. We're going to use something that we know does not exist in Llama. Who are the winner of the 2025 Super Buzz? So hate to disappoint Eagles sports fans, but let's see. Maybe it's going to be the Vegas odds. It might be who's ranked highest. It's what people are predicting. It's all different things. Let's see what it says. Boom. So what was it? Patriots New Orleans showdown in this case. Look, this is great. This is showing like when it totally has zero context. This thing just went off to start to make up stuff about Tom Brady. So interesting. So it's really making it up, right? And we're gonna do it again. 49ers in this case. Okay. So it's just in total lost world here. Yep. And so it's sort of, because it's totally lost, the next probability kind of predicts to some other line of information. You saw again, it kind of predicted back to like news articles from Tom Brady and the Patriots and stuff like that. And just set it down on a very, very weird path because it has just no context about what you're really talking about. 49ers again. You notice this actually changed the rest of it. Let's see. Was the 25 Super Bowl. Yeah, see, look, this doesn't even make sense in some ways, right? Again, it has zero context about what's going on. And so it's lying. All right. The more you ask these questions in controversial spaces, okay, sports, who's going to win a sports thing, arguably controversial, politics, controversial, especially when there's internet speak out there where there's a lot of false narratives and things like that. These things can go off onto the false narrative world. Be very, very careful about the models. Now, what, again, these GPTs of the world, the open AIs, all these kind of companies, they've kind of wrappered all these hallucinations and they're protecting them, but they're protecting them at the fine tuning and ChatGPT world. When you get access to that base model, it'll lie. Reviewing here again, scrape the internet for words, remove a bunch of stuff so it, is reputable. Tokenize it, and then train this network by training inside the green box, the math that happens in order to protect the next word. That's the base model. On another course, we're going to talk about what is non-base model, meaning the actual fine tuning that can happen. What I'm going to explain a little bit is how it kind of knows what the next prediction is. Okay. And this gets a little bit into understanding how AI works, and it's not as like technically on point, but I think it's good to explain. So I'm going to do a little drawing for you here. Okay. So I want to explain a little bit about how these words are related to each other. This kind of gets into what's called RAG, or retrieval augmented generation. It's this idea of how you sort of relate some words to the next with regards to these large language models. And I'm explaining from a RAG perspective because I think it's actually applicable to think about it for the large language model broadly. So we talked about GPT-4o having 200,000 tokens of vocabulary. Imagine if it was just three, and that three would give you an X, Y, and Z, because these things are sort of vectors at the end of the day. The tokens associated with like a paragraph of words. Okay. X, Y, and Z only. So instead of 200,000, X, Y, and Z only. So we're going to make a graph here. These are the axes. And now I'm going to make a dot here. Okay. And so there's this idea that you have a dot in the XYZ space up here. And there's really kind of an arrow pointing to that at the space. And then you have another dot here. Have another arrow pointing out there. Okay. The angle, would you kind of say these kind of things these two areas are related by the angle between them? A sinusoidal relationship. Okay. So we're back to trigonometry. Doing math like this to find out these kind of relative things is actually very, very easy to do when you're doing it with GPUs, which is why NVIDIA, it's a big talk around all that kind of stuff. Because it's just matrix math. Matrix math is done very, very efficiently by GPUs. GPUs originally, kind of originated from the graphics processing, meaning how it controls the screen. And the screen is just a big matrix of pixels. Okay. So again, collapse the whole internet down to sort of just, all things are in sort of just the three vectors, X, Y, and Z. Okay. Now I'm going to kind of say, let's, remove this idea of vector actually going out there, even though it's true. I just want to kind of clean it up. So you still have these dots here. Okay. All the same kind of ideas kind of cluster around each other. If you were to plot these things, these kind of have some level of sameness associated to them. And then over here, the ideas start to collect around each other because they have some sameness of where the vector of the XYZ is, and then out here. And so in this vector space, there's these clusters that happen. So we're going to bring up the fine web model here, and there's clusters of all these words. So kind of like the tokenization of them, right? They're tokenized is sort of the location of this little graph that you're seeing here in the 3D space. And here's what you see here is the text and all the language associated with those tokens in the 3D space. Okay. And they're kind of all about the same kind of issues. They've kind of, tagged these areas. These are like scholarship-y kind of things, and everything around here is scholarships, and here's film festival information. They kind of float in clusters. And I have an example, another sort of bigger example of that down here. Like this starts to get into like the massive idea of like, if you imagine that in the center here is the origin of the XYZ plane, all these kind of clusters form, and sameness ideas kind of come up out of this. Okay. I hope this is understandable, that these dots sort of collect together. So we've talked a little bit now about this kind of clustering that happens if you kind of look at all the vectors and these tokens as a group that are stored out in databases of these large language models. Again, think about 3D space, just X, Y, and Z. There's way more than that in reality, but last I checked, humans can't really understand the fourth dimension, let alone many more dimensions. So let's just look at X, Y, and Z here, and these sort of clusters that sort of start to happen. This is the last thing that I think is important from all of this context, is that ideas tend to group together. Okay. And so if you are talking about something that if you ask a Google type question, okay, and, I have a background in circuit board manufacturing. If I just start up ChatGPT and I gave it no other context, and I said, tell me about drilling. Okay. PCBs, we drill holes. Okay. If I just say, tell me about drilling, it's going to give me a very average answer because it's going to go somewhere in these little clusters out here to a place where somebody's talking about drilling. And it's going to talk about, oh, there's oil drilling, and then there's drilling of wood, and then there's drilling of PCBs, and all these kinds of different drilling. Okay. Um, so it's an average question that you get an average answer. Okay. But there exists somewhere very specific information about drilling oil, very specific information about drilling PCBs in different area clusters that, while they may be close to each other, you have to give it context to make it answer from a cluster about PCB drilling versus a cluster about oil drilling. Okay. The only way you're going to do that is you have to give it that information. You have to say, hey, I need you to answer the question I'm talking about as a professional, you know, oil rig drilling guy, right? Or as a professional PCB manufacturer. And once you give it that context, one, it's going to get away from the averageness. And now it's going to answer it from that space of being more of a professional. Okay. Many different ways to kind of prompt that. We talk about those things in the community. But that's the idea. If you phone in your interactions with GPT, you're going to get very average answers. And are they accurate? Yeah. Or if you have a report written with these average questions, is it going to be done faster and smoother? Yeah, it is. And that's why I think that, people will use these models in order to not have consultants for certain areas, because it's a good enough answer. You keep on honing in what you're trying to get out of it, but you didn't need to hire somebody to tell you this information, nor did you need to look it up necessarily on the internet. And if you didn't understand what the information that came back is, you can have the GPT teach you it in whatever method you want. But when you don't give it context, it's going to give you average answers. And so people's socks aren't necessarily blown off when they first start using it, because people tend to ask very basic questions. They tend to ask the Google search question: what is drilling? Okay. You got to tell it, hey, I'm doing X, Y, and Z. This is what's going on around it. I want you to think about it from an expert point of view in this area of the world. So I think that's one of the most important takeaways for everybody for the use of LLMs in general. You got to give it information. Stop being lazy in the way you ask things. Okay. There's a balance. If you're just asking for the quick question, sure, you can do it. Just know what you're going to get out, and it's going to be accurate, and it's just going to be average. And it saves you time if you're just asking for that quick question. But if you're really trying to use AI as a thought partner, which is what I want everybody to really be thinking about, you gotta put the work in. Okay. And the more work, by the way, you put into it, the more it builds context about you over time, or really within that chat. Doesn't necessarily have memory as we think about computer memory, but within the same chat, opened up that chat, you can get a lot of stuff, a lot of context built in there, and you'll really start to get good answers. But you got to start that chat with really good context, role, task. Again, reference the CRIT method in our community. And maybe you'll understand why it's really important now, because these tokens are just next work predictors, and they kind of cluster together. And there is concepts that bring them to clusters unto themselves. And if you're only asking it average questions, it's going to go to a cluster that is very generalist. And if that's what you need, then okay, just understand what you're getting. And so if you really want to use this as a business partner, you gotta move it to the right cluster. So that's it for this training. I encourage everybody to participate in the community. And if you're not in the paid part of the community, we're just trying to cover the cost of running the community. I encourage you to do that. We're having a lot more ideas and sharing conversation over there. Everything that you can access from the non-paid side is just showing you examples of what we're talking about.